Welcome back, everyone. In this tutorial, we're going to unlock the secrets of PGP encryption in Java. Encrypting data securely these days is vital, and pretty good privacy, or PGP for short, is one of the most robust solutions out there. Are you ready to learn how to implement it step by step? Let's dive in. First, let me give you a brief overview of what PGP encryption is. PGP combines both symmetric and asymmetric encryption to provide a secure way to encrypt and sign your data. It uses a pair of keys, a public key that can be shared with anyone and a private key that is kept secret. When we encrypt a message with a recipient's public key, only they can decrypt it with their private key. This way, we can ensure confidentiality and authenticity. To get started with PGP in Java, we will be using the Bouncy Castle library. Bouncy Castle is a widely used library for cryptographic operations in Java. So, let's include the necessary dependency in our project. If you are using Maven, add this dependency to your pom.xml. After adding the dependency, let's create a new Java class called PGP Encryption Example. This class will be our main class for demonstrating PGP encryption. Here's how to create it. Let's start by generating a key pair, a public and a private key. This key pair will be used for encryption and decryption. In the following code snippet, we'll be defining a method to generate this key pair. Now, we're going to call our generateKeyPair method in the main function and print out the generated keys. We need to create a PGP secret keyring, which is a collection of public keys. Next up, we need to export our public key to a destination. This will allow others to encrypt messages that only you can decrypt. Let's add a method to export the public key. Inside our export public key method, we'll be using the PGP public key class to create a stream and write it to a file. For demonstration purposes, let's save the public key to a file called public_key.asc. Now that we have our public key saved, let's move on to encrypting a message. To do this, we will create another method called encryptMessage. This method will take the plaintext message and the public key to generate the encrypted message. In the encryptMessage method, we will convert our plaintext message into a byte array, apply the encryption with the public key, and return the encrypted message as a byte array. Now let's call our encryptMessage method with some sample data. In the main function, we will test encrypting a sample message. Let's add that now. Next, it's time to decrypt the message. We need another method, decryptMessage, that will take the encrypted byte array and the private key to return the decrypted message. In the decryptMessage method, we will read the encrypted message, decrypt it using the private key, and return the original plaintext message as a string. Finally, we will need to demonstrate decryption in our main function to complete the encryption-decryption cycle. Let's finish up by calling our decryptMessage method. And with that, we have a fully functional PGP encryption and decryption mechanism implemented in Java. By following these steps, you can securely exchange messages or files. Make sure you protect your private key and share your public key wisely. As a recap, we have successfully generated key pairs, exported the public key, encrypted a message, and finally decrypted it. The beauty of using PGP is its ability to ensure data integrity and confidentiality. Before we end this tutorial, make sure to subscribe and hit the bell icon so you won't miss any of my coding tutorials in the future. If you have any questions or comments, drop them below, and I'll be more than happy to help.